And then when you take the derivative of this, we end up with this right here, guys, right? Because that right there is 2y. 2y times 2h is equal to 4hy. And that is 3xy squared. You factor that out, and that's what we end up with. We set it equal to 0. And what we end up with is, let me grab this out, guys. Sorry about that. There you go. I don't know if this new way of recording works for you guys, but this has saved me a little bit of time in the length of recording, that is. All right, guys. So you set it equal to 0, then we know that the y is equal to h, or y is equal to 3. And I don't know why I have that over there. That was for some other reason, by the way. And then we have the values. So what can y be? Y here could be from 0 to h. That's it, right? Okay, so the v prime is 0 here and here. So what we could do is just plug in some values. And if you plug in a value that's between 0 and h over 3, you get a positive slope. The v prime is positive. And here it's negative, so it goes up and down, so that's maximum, right? There is another way to tell, but let me hold back a second. So we know that that's the maximum right here, so that can't be it, right? Because it's going down, so that value is less than this value, okay? So you get maximum volume when y is equal to h over 3, and when you plug it back in, you end up with this volume, guys, okay? All right, so initially you saw me with y equal to 0. Why did I do that? There is another way to sort of test this, right? This is the way that I prefer you do this. However, the y value is from where to where? From 0 to h, right? Ask yourself this question. What happens if my y value is 0, right? If y value is 0, my x value is r. When you plug into the volume over here, it's 0, right? So my volume is 0 when my y value is 0. What if my y value is equal to h? When it's all the way up here, then my x value will be 0. My radius will be 0, which means that my volume will be 0 here. Now, according to the Rolle's theorem, right? Rolle's theorem, if you have the values that two are the same and this function is continuous and differentiable, and by the way, you know the area here, the volume here is positive, right? So it will go up and down. There's at least one point in which, right, it will be whose slope will be 0 right here, right? And because there's only one point in the middle, right, where there's a curve, that has to be the maximum. Okay, so there's at least one point in which that happens, right? And we found one, and so that has to be the relative maximum. Okay, you don't really need to do this part over here, but this is the one that's most acceptable, right? And then let's address the second one. I kind of went through this equation kind of fast, so this is a bonus material, but here it is. So I kind of wrote that out as well. Sorry about that, guys. Here we go. There you go, guys, right? Now, more on linear equation. When you have ax plus by is equal to c, we call that general or standard form. And you can put the c either to the right or to the left and set that equal to 0. And one of the more useful linear equation was a slope-intercept form that we did so much time in the middle school. So that's the starting value, or y-intercept, when that's the rate or the slope, right? But the one that I favor, especially for high school math, is this, because it's much quicker, right? You only need a point and a slope. X naught, y naught is the point, and m is the slope. This right here, if you have intercept values, which we do in this case, right? Our intercept value, the cone over here, is r in the x-axis, and the y-axis is the height, right? Right. When you have that kind of shape, x over a plus y over b is equal to 1 is called intercept form. And the a is the x-intercept and b is the y-intercept. And if you look through that carefully, it's kind of self-evident. So when you have a linear equation whose y-intercept is 5, x-intercept is 7, that's the way to go. Now, I suppose you could do this way, find the slope and y-intercept to do this, but I think having an intercept form is a little bit quicker. The reason why I think it's quicker is that when you're looking at this particular scenario, I could find this equation immediately, right? Whereas if I do this, I need to figure out which of the proportions that I want to choose. It's either this triangle and that triangle and then a large triangle. The height to width, the height to base ratio is equal to each other. So you got this and this, and there's one more possibility, right? So I tend to favor this, but it's really up to your comfort level, right? All right, guys, and that is it for me, and that is the correct for that is it for lesson 4.7, I believe, the optimization. All right, all right. Thank you, guys.